Okay, Algebra 2, we're looking at attributes of cube root functions today. Yesterday we did cubic functions, and that would be x to the third. Today it's cube root, and it's going to be the cubed root of a number. You're going to discover that they are very similar. When you start by looking at their key attributes, the domain for a cube root function is all real numbers. The range is also all real numbers. There is exactly one y-intercept, and there is exactly one x-intercept. The graph has rotational symmetry around a point. Every one of those key attributes applied for cubic functions as well. If you look at the graph, what you will notice the only difference is that this graph goes sideways instead of up and down. So, when you analyze the key attributes, if you graph it and figure out what the domain and range and intercepts are, you're going to get that from your calculator, from your graph. Okay, so you're going to start by taking what they gave you and putting it into y equal, and then you would make a table. They recommend that it's convenient to use x values that are perfect cubes. If you're having to do this on your own, like without a calculator, you'd want to get perfect cubes. So anyway, if you do that and you plot those points and you have your arrows on the end, you're going to discover that the domain and the range will be all real numbers, ARN. The x-intercept and the y-intercept will both be at the point 0, 0 for the parent function. And you have a rotational symmetry around the origin. Remember, if you translated it, transformed it, rotated it 180 degrees, it would cover itself perfectly back up. It's symmetrical. Okay, going to the next page. I'm not going to have you actually graph any of these, okay, because you can put it in y equal and look at your graph on your calculator. When they give you a cube root function and ask for the minimum and the maximum on a given interval, anytime they are giving you an interval, they are giving you the x values. You put that number in for x and see what you get. The smallest number is obviously going to give you the minimum. So the small number they gave me was 0. So this would be f of 0. In other words, the cubed root of 0 is 0. So the minimum is 0 over that interval. Not for the entire graph, just for the interval they gave us from 0 to 6. Then to find your maximum, you're going to go and put your 6 in. And so then it would be the cubed root of 6, and 1.817 is the maximum over the interval. So if they give you the cubed root of x minus 5, and they're having you look at the interval from 4 to 7, you're going to say the cubed root of 4 minus 5 for your minimum, and you're going to say the cubed root of 7 minus 5 for your maximum. And you just do this in your calculator at your home screen, okay? Except that cubed root's not really great, so we're going to be raising it to the 1/3. The cubed root is raising something to the 1/3. So open, and you're going to say 4 minus 5, close, rooftop, open, 1 divided by 3. It's important that that 1/3 is in parentheses, and you get -1. So then when you do the same thing again, so I'm just going to do second enter, come over here, and I'm going to change my 4 to a 7, because that was the largest number of the interval that they gave me, and I have 1.259, so 1.26. And that's your answer. I'm not going to have you graph it. You don't have to really compare a lot, okay? I want to know what is the minimum value, what is the maximum value. You put the small number in, see what you get. You put the big number in, and you see what you get. Okay, so sometimes they're going to give you a specific situation. The graphing of the function, the cubed root of x, is talking about the edge of a cube, specific thing in real life. Okay, we're talking about the volume. When you have a cube, when you have a volume, it must be non-negative, otherwise known as positive. You cannot have a negative length of the side of a cube. So they're only going to look at the first quadrant of your graph. Your x and y intercept are still at 0. And your domain is no longer all real numbers. Your domain is going to be x is greater than or equal to 0. and your range is going to be y is greater than or equal to 0, because we do not go down below the x-axis or to the left of the y-axis. Okay, so your domain is now x is greater than or equal to 0, otherwise known as all positive numbers. Your range is y is greater than or equal to 0, otherwise known as all positive numbers. X and y intercepts are still 0. Okay, that's just when they give you a specific situation. Going to the next page. Okay, inverse. We studied inverse a long time ago, and you use the same rule now. When you are going to find the inverse, this is your starting point, okay? You rewrite it and you use it with y instead of f of x. Then you switch your x and y, and then you solve for y. Those are your 3 steps. Rewrite it with y, swap your x and y, solve for y. So the original problem was f of x is equal to 2 times x minus 1 to the third plus 1. So they rewrote it, changed it to a y. They swapped spots with the x and the y. Now the key thing is you've got to move anything on the outside of the parentheses first. So they subtracted the 1 and they divided by 2. Remember, when you cross the equal sign, you do the opposite. So then you have something cubed. To uncube it, you take the cube root of everything on the other side. And then at the end, you move whatever was left, and it does not go under the cube root. See how it's at the end of the whole thing. Once again, you will not be required to graph, okay? I'm not really worried about describing the relationship. For our lesson today, I want you to be able to find the inverse. If they give you 2 cubic functions and they want you to prove that yes, they are inverse or no, they aren't, you use what we call composition of functions. You put one function in the other. So if I put all of this in for x here, and it simplifies down to plain old x, and then if I go the other way and put all of this in for the x in the other one, and it simplifies down to x, then yes, they are inverse. If either one does not simplify down to x, then you say no, they are not inverse. Okay, go to the next page and let's do some together. All right, graph each. Once again, you do not have to graph each cube root function, but you're going to analyze the domain, the range, and the intercepts. So looking at the first one, I'm going to start by putting it into my calculator at y equal. So let's clear everything out. And we're going to say the cubed root, so that is actually x to the 1/3. X rooftop open 1 divided by 3, close parentheses, minus 2. You could get cubed root in your calculator, but you have to go through one of the menus, and it's just as fast to do this. Except I should have been at y equal. So x rooftop open 1 divided by 3, so that's your x, that's the cubed root of x, and then you're outside of that, so minus 2. So to start with, if you want to look at your graph, you can. Doesn't really matter. Because we know that when we talk about the domain and the range, that it's always going to be what? All real numbers. So domain and range are all real numbers. You need an x-intercept, and you need to give me a y-intercept. You're going to get that from your table. Go to where x is 0, so let's just tell it to start at 0. And when x is 0, y is negative 2. That is my y-intercept because the value is actually for y. So y is equal to negative 2. Then you're going to look over here for your y to be 0, so you'll have your x-intercept. And when y is 0, x is 8. So my x-intercept is 8. If for some reason it went from positive to negative, but it skipped over 0, you would need to find it. You would go second, calc, number 2 for 0, get to the left, enter, get to the right. Remember, we're finding the x-intercept, so you got to get across the x-axis, enter, enter. And it tells you that it is at 8. Okay, so now when you go to the next one, you're going to do open, x minus 1. You're going to do everything that was under that square root, x, or cubed root, x minus 1, close. Rooftop, open, 1 divided by 3, close parentheses. and go to your table. Now think about it. You may want to just look at your graph. What should your domain and range be? What will your domain and range always be? All real numbers. Okay, domain and range are both all real numbers. Then you want to look at your table. When x is 0, y is -1. So y equal -1 is your y-intercept. And then go to your table, and when y is 0, x is 1, so x equals 1 is your x-intercept. And you have done all you have to do for this. Don't worry about the symmetry. Yes, it is symmetrical. We're not going to focus on that right now. All right, once again on the next one, we're not going to worry about graphing it, but we want to know the minimum and maximum. So minimum and maximum over the interval of -8 to 0. So to find your minimum, you put -8 in for x. So you would do this at your home screen. And so open -8, close rooftop, open 1 divided by 3. Remember, raising it to the 1/3 power is the same thing as finding the cubed root. And then once you're on the outside of that, you're going to say +1. And so you get -1. So your minimum value over that interval is -1. Then you're going to do it again. So second enter to pull it back up. And instead of -8, we're going to use 0. So this is a 0, and you need to go over there and delete that negative. And when you do that, you get 1. And so that tells you that your maximum is 1 over that interval. Okay, so this is going to be the same thing, except when you put it in, let's just clear this out. You're going to say open, and you're going to say -2 plus 2. -2 plus 2, remember we're finding the minimum first. Rooftop open, 1 divided by 3, close. And there's nothing after that, so you would just enter, and so your minimum is 0. And then to do your max, you're going to do second enter to pull it right back up. And you're going to change the -2 to a +6. So delete the negative, put a 6, enter, and your maximum is 2. So over the interval, the minimum value is 0 and the maximum value is 2. Okay, so now they've given us one and they want us to find the inverse. So we start by rewriting it with y. I'm going to do 2 steps at once. I'm going to swap my x and the y, and I'm going to rewrite. So instead of y, I'm going to say x is equal to 1/2 times y plus 2 to the 3rd. I need to move that 1/2. When I take it to the other side, it's like you're dividing by 1/2, which technically is multiplying by 2. So 2x is equal to y plus 2 to the 3rd. I'm going to have to uncube it, so this becomes the cubed root. So the cubed root of 2x is equal to y plus 3. No, y plus 2, my bad. So then that 2 moves, and so your final answer is going to be the cubed root of 2x. And then you're going to have a -2 for where we move that outside of it, is equal to y, which we're going to change to f -1 of x, because that shows inverse notation. Now I combined several steps. I changed it to y and swapped my x and y at the same time right here. And then I moved my 2 and changed it from y to f -1 of x over here. This right here is what your final answer looks like. And then the last thing is to use composition of functions to figure out if they are inverse or not. So if you say 4 times the cubed root of x over 4 to the 3rd. This whole thing is to the 3rd though. 4 to the 3rd is 64. If you raise something that's cubed to the 3rd power, it becomes, you just cancel the cubed root and the cube out. So it's 64 times x over 4. 4 cancels into 64. 16x is what you get. Is this just plain old x? No. So they are not inverse. Okay, this has you ready to get your assignment.